Alright, hi everybody, we're working through the Diploma prep material. This is the chapter on trigonometry. We want to solve this equation, providing not only the specific solution in the domain that they've given here, but we also want to do the general solution to this. Okay, now, as soon as we start looking at an equation like this, that has got kind of multiple trig functions in it, sometimes it's hard to get lost. It's easy to get lost in the algebra here. And that's mostly because the cosines here can be a little hard to work with. So, look, do I know what theta is? No, that's the whole point. I'm trying to solve for theta. But if I don't know what theta is, I don't know what cosine of theta is. So this is essentially an unknown. So I'm just going to put a big X over it. And that makes this equation 5x minus 6 equals 3x minus 5. Now what I want to do is I just want to solve for x. Because there are two levels to this problem. There's the algebra, like basically the polynomial part of this problem. Then there's the trig part, and it really is that order. Deal with the polynomial stuff first, then the trig. So bring the 3x over, bring the negative 6 over, and it becomes positive 6, so it becomes 1. So x is equal to 1/2, which means the cosine of theta is equal to 1/2 when I put the cosine back in. Now I'm dealing with an interval here from negative pi to 2 pi. So what that looks like, if I look at the domain here, negative pi is a rotation, half rotation this way, and then 2 pi again starting on the positive x-axis comes all the way around. Notice that cosine is positive, so that means quadrants 1 and 4. And I can see that there are 3 distinct points of intersection there. So I'm assuming 3 specific solutions in the domain that they've given me. I want to find my reference angle. Okay, that is going to be the inverse cosine of 1/2. Okay, which gets me pi over 3 or 60 degrees. So now I'm just going to follow my rotations here. So my theta is going to equal, well, okay, let's do the negative one first. If I sit here on the positive x-axis and rotate pi over 3 units negatively, okay, my answer is going to be negative pi over 3. And that is the only time that my negative rotation intersects one of those lines. So then I move to my positive rotation, starting on the positive x-axis. I'm going to rotate counterclockwise. The first time I hit it is right here in the first quadrant, which is going to correspond to the reference angle, pi over 3. Then I'm going to go around, keep following this. I'm going to come all the way around to the fourth quadrant. Now, pi over 3 is dividing the top half of the circle into thirds. It also divides the bottom half into thirds, which basically means that I'm looking at something like this. Okay, 3 in the numerator, not numerator, 3 above the x-axis, 3 below. So to come all the way around to here, that's 1, 2, 3, 4, 5 pi over 3's, going around that full circle there. Okay? Now, those are the specific solutions, I should say. Okay, the general solution, what I got to do here is pick basically 2 representatives, okay, for these 2 lines here. Now, normally what we would do is we would pick the positive ones, what we might call the principal angles. So normally what I would do is I would label this as pi over 3 and 5 pi over 3 to represent each one of those, to represent one of these lines here, pi over 3, 5 pi over 3. And I will add to that n times 2 pi, where n is an element of the integers. Now, the symbol for integer is z. Okay, I know sometimes we use I, but technically the symbol is supposed to be a z here. Notice I'm not going plus or minus n2 pi, because I'm going to let n be an integer, so n is either positive or negative. And 2 pi indicating full rotations. Okay? And this is how I get a general solution. This is how this is now extended to the entire domain.